hi everyone, a very good evening and welcome to today's live session. So as you all know, today we are doing a refresher session for the SSC CGL exam Tier 2 examination. I hope all your preparation for the SSC CGL Tier 2 examination is in full swing. Okay, and today's session we are going to be focusing on the topic of geometry, which is a very important topic for SSC CGL examinations, and we are going to be doing a refresher session. So what we are going to be doing is we are going to take up previous year questions that has been asked from geometry, and we'll be solving these questions in today's session so that it's helpful for you when you prepare for this particular topic for the upcoming examination. Okay, and coming to geometry, the most important thing in geometry that you need to know is the theorems and properties. Okay, so there are there are mainly three types of figures that comes in geometry. Okay, if you see, you'll have questions on circles, then on triangles and on quadrilaterals. Mainly these are the three types areas which is covered in geometry for SSC CGL. Now if you see the question papers, you can see questions repeating from these three sections. Now the first thing that you need to know is there are a few theorems for each of these type of figures which you should be very good at, and you should also know properties, okay, of these figures. And when we say theorems, there are also a few terms. Let's say if you are taking into consideration a triangle, you should know what is a median, what is a centroid, what is an incenter, and the corresponding properties of these. Okay, similarly when you look at circles, you should know what a tangent is, what is a chord, properties of tangents, properties of chords, right? So that is the most important thing. If you know the theorems and the properties very well, then solving questions from geometry becomes easier. Okay, so let me share my screen and we'll go about solving the questions directly. As and when we solve a question, we will also discuss the property or the theorem that is related to that particular question that you will have to use to solve the question. Okay, the first question is there on your screen. In triangle ABC, angle B is equal to 60 degree and angle C is equal to 40 degree. AD and AE are respectively the bisector of angle A and perpendicular on BC. The measure of angle EAD is dash. So let us represent the given information in the terms of a diagram. So this is A, B and C. It is given that AE is the perpendicular on BC. So this is AE, it is the perpendicular, then you have AD, right? This is dividing this into two equal angles. It is, what is AD doing? See, it is given that AD is the bisector of angle A. That means AD divides angle A into two equal halves. You know, this is 60 degree and this is 40 degree. So what can you say about angle A? See, here you make use of the property of triangles, that the sum of angles of a triangle is equal to 180 degree. So angle A is equal to 180 minus 60 plus 40, correct? That is 180 minus 100, or that is equal to 80 degree. So if angle A is equal to 80 degree, then what is this AD doing? It is dividing A into two equal halves, correct? So this is 40 degrees and this is also 40 degrees. So that much you know. Now the question is, you have to find what is this angle, correct? That is, what is angle? You have to find what is angle EAD. This is what we have to find. Now how do you find that? To find that, first let us consider the triangle BAD. Now if you look at triangle BAD, so you know this angle is 60, this angle is 40. So what is this angle? That's going to be 80 degrees, correct? So this is equal to, you know that if you consider triangle BAD, you know angle ADE, that is equal to 80 degrees. Now consider this triangle AED. Now consider triangle AED. In triangle AED, you know this is 90 degree and this is 80 degree. So what is this angle going to be? It's going to be 180 minus 90 plus 80, or that is equal to 180 minus 170, or that will be equal to 10 degrees. So I can say angle EAD, that is the required angle, that is equal to 10 degrees. That is option D. The next question is there on your screen. I is the incenter of the triangle ABC if angle ACB is equal to 55 degree, angle ABC is equal to 65 degree, then the value of angle BIC is dash. So how do you solve this? What is given in the question? So you have a triangle ABC. Now I is the incenter. So what is an incenter? You should know what an incenter is first to solve this question. See, incenter is the point where all the three medians of a triangle join, correct? So this is the incenter. So they have said this is given as I. I'm just taking this as I. Okay, now what are they saying? This angle ACB is 55 degrees and ABC is 65 degrees. Now the question is, what is the angle BIC? So this is, that is the question. Now a lot of you are giving me the answer for this, as some of you have said it is option C. Okay, so here again you have to use a property, that is the angle formed by any side at an incenter is always 90 degree more than half the vertex angle opposite to the side. Okay, so what is the property that we are going to use here? See, the property here is the angle formed by any side. Okay, let us say this is the side BC. This is the side that we are going to consider now. The angle formed by this side, for example, at an incenter is always 90 degree more than half the vertex angle opposite to the side. What is the vertex angle opposite to B? It is this angle, correct? So this angle is going to be 90 plus half of angle A. That's what the property says. So directly put in the value. See, this is 65, this is 55, means you know what is this. See, again sum of angles of a triangle is 180 degree. So 65 plus 55 plus x, whatever, A, that is equal to 180 degree, or directly you can get x is equal to 60 degree, correct? So angle A is 60 degree. So if this is 60 degree, what is this going to be? It's going to be 90 plus half of 60, or 90 plus 30, that is equal to 120 degrees. So that's option C. Yes, everybody got the answer correctly. Good. Again, somebody is giving me the answer as 150. No, that's not the correct answer, Mahata. The correct answer is 120. So what property have we used here? We have used the property that the angle formed by any side at an incenter is always 90 degree more than half the vertex angle opposite to the side. So using that property, we got angle BIC, right? That's what you have to find, that is equal to 120 degree. Yes, so everybody got it correctly. Good. Let's move on to the next question. The next question is there on your screen. So this is on similar triangles. Triangle ABC is similar to triangle PQR. Length of AB is 18 centimeter and length of the corresponding side PQ is 12 centimeter. If area of triangle ABC is 324 square centimeter, what is the area of triangle PQR? So how do you solve this? Again, to solve this question, we make use of a property of similar triangles. Okay, if you give very easy question, if you get, give me the answer. Okay, see, the property that you use here is, if you have two triangles which are similar, then the ratio of the areas of the two similar triangles is equal to the ratio of squares of its corresponding sides. So you have two triangles here, correct? See, the area of triangle, ratio of area of two similar triangles. Here the two similar triangles are ABC and PQR, correct? The ratio of areas of two similar triangles is equal to the ratio of squares of the corresponding sides, correct? If you have the corresponding sides, let's say here the corresponding sides are what? What have they as PQ, correct? What is as AB and PQ, correct? So corresponding sides, if it is AB and PQ, then you can say it is AB squared by PQ squared. Or if you are considering the side BC, correct, then it is also equal to BC squared by corresponding side here is going to be QR squared, and so on, correct? So the property that you are going to use here is, if two triangles are similar, the ratio of areas of two similar triangles is equal to the ratio of square of its corresponding sides, correct? A lot of you are giving me the correct formula. Good. So just put in the values in this formula and you get the answer. See, you know area of triangle ABC is 324. Now you don't know what's the area of PQR. correct? So let's keep it there. That is equal to length of AB is given as 18 centimeter and length of PQ is given as 12 centimeter. Equate this, you get the area of PQR as 144, correct? That is 324 into 12 squared divided by 18 squared. Yes, so all of you have got the answer correctly? Correct. 144. Good. Because 18 squared 324 will get cancelled, directly you get 12 squared. Okay. Let's move on to the next question. Good. Next question is there on your screen. Again, it's on similar triangles. Again, the same property that we used, but question looks a bit different, that's all. Here, triangle ABC is similar to triangle DEF. If area of triangle ABC is 9 square centimeter and area of triangle DEF is 16 square centimeter and BC is 2.1, then the length of EF will be dash. So here they have given area of the two triangles and one corresponding side is given. You have to find the length of the other corresponding side. The same formula that we used, just replicate it here and give me the answer. Same formula to be used, area of triangle ABC by area of triangle, here the triangle is DEF, right? That is going to be equal to BC, correct? BC squared by EF squared. So you know this is 9, 16, that is equal to, this is 2.1 squared divided by EF squared. So what can you say? You can say EF squared is equal to 2.1, that is 4.41 into 16 by 9, correct? Or I can say EF, you can just take the root of all of these, correct? So directly you can say EF is equal to 2.1 into 4 by 3, that is 2.1 by 3 is 0.7, 0.7 into 4 is 2.8, option B. Let's move on to the next question. In triangle ABC, angle A is equal to 70 degree, angle B is equal to 80 degree and D is the incenter of triangle ABC. Angle ACB is equal to 2x, angle BDC is equal to y degree. Then the values of x and y are respectively dash. What is given? There is a triangle ABC, okay, ABC where angle A is 70 degree, angle B is 80 degree and okay, so what is angle C going to be? Okay, let's see if we need actually angle C. Okay, now what is given? D is the incenter. D is the incenter of ABC and it is given, so D is the incenter of ABC. It is given that angle ACB, okay, that is equal to 2x degrees and angle BDC is given as y degrees. Now very easy, no? How do you find angle ACB? See, this is 80 and this is 70. Correct. So what is this going to be? 80 plus 70 is 150. So angle ACB we know is going to be 180 minus 150, that is 30 degree. Correct. Now this 30 degree is what? It is equal to 2x. So what is the value of x? 30 by 2, that is 15. Now next you have to find what is y. Again, to find the value of y, you use the same property of incenter. Correct. What was the property of incenter that we used? Like we used, I think in the question number 2, we used the same property. That is the angle formed by any side at an incenter is always 90 degree more than half the vertex angle opposite to the side. So what will this y be? This y is going to be 90 plus half of 70. Correct. That is the angle to the opposite vertex of the side BC. Correct. Or 90 plus 35. So this is going to be the value of y and x is 15. So what are they asking? This is 125. So option is what? B. 15 and 125. Yes. Good. So everybody got it. So I hope all of you got this answer as B. So let's move on to the next question. The next question is there on your screen. In a right angle triangle DEF, if the length of the hypotenuse EF is 12 centimeter, then the length of the median DX is dash. So again you will have to use the a property of the right angle triangle here to solve the question. If you know the property, then the question answer you get it in a second. So see, that is why I say that it is very important to know these properties. Okay, so what you need to know here is that if you have a right angle triangle, okay, the line joining the vertex of the right angle to the hypotenuse, correct, to the midpoint of the hypotenuse is always half the length of the hypotenuse. So remember that. So if you know this, solving the question becomes very easy. So here in the question it's already given that EF, correct. So if this is D, this is E and this is F. Here it is given that EF is 12 centimeters, correct. So this length, this one is going to be half of this 12 centimeter, this is going to be 6 centimeter. This is dx, correct. So always remember, in the right angle triangle, the median that you draw from the right angle will always be equal to half of the hypotenuse. Yes. So this is 6 centimeter, that is option C. Very easy question. So let's move on to the next question. The next question is there on your screen. In triangle ABC, DE is parallel to BC, where D is a midpoint on AB and E is a point on AC, and DE divides the area of triangle ABC into two equal parts. Then DB is to AB is equal to dash. So try this question and give me the answer. So anyway, let me just draw what information is given in the question. DE is parallel to BC, where D is a point on AB and E is a point on AC, and DE divides the area of the triangle ABC into two equal parts. So what does that mean? It means that area of triangle ABC, correct, divided by area of triangle ABC ADE, that is equal to 2 by 1. Okay. See now, when you see this, what can you say? See, when you draw a parallel, okay, to BC, that is DE, you can see that ADE and ABEC both are similar triangles, correct. So since both are similar triangles, what can you say again? They have also told us that this line DE divides the area of triangle ABC into two equal parts, or I can say that the full area of triangle ABC divided by the area of the small triangle ADE is equal to 2, correct. That's what it means. Now since triangle ADE and triangle ABC are similar triangles, we can use we know a formula, right. So if you have two similar triangles, the ratio of their areas will be equal to the ratio of the squares of their corresponding sides, correct. So if you look at triangle ADE and triangle ABC, correct, ratio of the areas of these two triangles will be equal to square of the ratio of the corresponding sides. So if you look at the corresponding sides, you have AB and AD. So I have just taken AB and AD squared. See, it is given in the question that this line is dividing this triangle into two equal halves. So what does that mean? See, let us say the area of this full triangle is x. Okay, if the area of this full triangle is x, the area of this ADE is going to be x by 2. Similarly, this is also going to be x by 2. Correct. Or what can I say about the area of ABC by ADE? It is nothing but x by 2, or that is equal to 2, correct. Or see, area of this full triangle is equal to twice the area of this small triangle. This line DE divides this big triangle into two equal halves, correct. So what does that mean? This whole triangle's area is going to be twice the area of this small triangle. That's how I take it as 2 by 1. Okay. Now you know this is equal to AB squared by AD squared, correct. Now next, what is given? Okay, or I can say AB by AD, correct. Here since this is AB squared by AD squared is equal to 2, I can say AB by AD is equal to root 2, or you can say AD by AB is equal to 1 by root 2. See, remember, you have to find what is DB is to AB. So basically I am going to try to arrive at this what is DB is to AB. That's why I am doing this. Now you might ask me, why are you reversing this? You know what is AB by AD is equal to root 2. So why am I actually writing it in reverse? Somehow I have to reach to the ratio dB by AB. To get that, I am just writing the reciprocal of this AB by AD. So you know AD by AB is 1 by root 2. Now just subtract 1 from both sides of the equation. So what do you get? You get 1 minus AD by AB, that is equal to 1 minus 1 by root 2. Or if you take the LCM, you will take the LCM here, it will be AB minus AD by AB is equal to root 2 minus 1 by root 2. Now what is AB minus AD? AB minus AD is equal to dB. So this is equal to dB by AB. So that's how you get the answer as option C, that is root 2 minus 1 by root 2. Okay, I hope it is clear. Good. Let's move on to the next question. So the next question is there on your screen. ABCD is a quadrilateral in which diagonal BD is equal to 64 centimeter, AL is perpendicular to BD and CM is perpendicular to BD such that AL is equal to 13.2 centimeters and CM is equal to 16.8 centimeters. The area of the quadrilateral ABCD in square centimeters is dash. So in this question basically you are given a quadrilateral and you have to find the area of the quadrilateral. So try to solve this question and give me the answer. Again, if the logic clicks, it's a very easy question to solve. Always try to draw the figure. Whenever a question on geometry comes, try to represent the given information in terms of a figure, then it will be very easy for you to. So what is given? See, there is some quadrilateral. Let's say this is the quadrilateral that you have. Okay, quadrilateral is just a four-sided figure. So, and what are they said? ABCD is the quadrilateral, ABCD, and it is given that BD is 64 centimeter. Correct? This length is given as 64 centimeters. And AL is parallel to BD. That is basically there is a perpendicular drawn from this vertex. So this is AL. Okay? AL is parallel to BD and CM is again parallel to BD. So you are drawing another perpendicular from here. So let's say just this point. This is M. Now they have given what is the length of AL. It is given as 13.2 and this is given as 16.8. Now you have to find the area of this quadrilateral. Now see, if you look at this figure, what do you see? Actually this quadrilateral is comprised of two triangles. There are two triangles here, triangle ABD and triangle BCD. Okay. Now if you find the area of these two triangles, then finding the area of this quadrilateral is very easy, right? Sum of the areas of the two triangles, that's all. Now why did we split it in terms of triangle? See, because if you look at this triangle ABD, now you know this base length of the triangle. You also know the height of the triangle. So for any given triangle, if the base measure of the triangle and the height of the triangle is given, we know the area of the triangle is given as half into base into height. Correct? So you can very easily find the area of both the triangles. Now if you look at triangle ABD, what is its area? Its area is nothing but half into the base. Here is going to be 64. Correct? Half into 64 into the height. Height of this triangle is 13.2 plus the area of triangle BCD, that is again equal to half into 64 into here the length, height is 16.8. So this is going to be the net area of this quadrilateral. Now again when you solve this, see, don't simplify, don't start multiplying here, it's going to take a long time. Even if you use speed math, it's going to be a waste of time. So what you do at this step is, you can see that this 64 and 1 by 2, that is common, take it out. Okay, so inside you will be left with 13.2 plus 16.8. Okay, now you know what is 64, this is 64 by 2. Okay, just solve this. Very easy to do it that way. 64 by 2, you know it is 32. Now 13.2 plus 16.8 is going to be 30. So 32 into 30, that is equal to 960 is going to be your answer. That is option B. Okay, yes. Good. Now let's move on to the next question. The next question is there on your screen. If ABCD is a square and BCE is an, where is BCE? Yeah, BCE is an equilateral triangle. What is the measure of the triangle? What is the measure of angle DEC? So angle DEC, you have to find out what this angle is. So see what is given, it's a square. First thing, property of square that you need to know is all the sides of a square are equal, correct? So all these sides are going to be the same. Now ABCD is a square and it is given BCE is an equilateral triangle. So that's the clue given here. So if this side BC is X, then these sides are also going to be the same, right? See, all the three sides of an equilateral triangle are the same. So if this side, that is whatever is the side of the square, that's going to be the length of CE and BE, correct? Or I am just writing it down. See, you know, in a square AB is equal to BC is equal to CD is equal to AD, and this is also equal to CE is equal to BE. Because this is an equilateral triangle, remember all the three sides of an equilateral triangle are going to be the same. So now look at this triangle now. Okay, if you look at this triangle, you consider triangle DCE. Now what is the angle that you have to find? You have to find what is DEC, that is this angle you have to find out. Now let me just redraw this figure here little big so that it's clear. Yeah, so this is the thing that you have. Now since this is an equilateral triangle, you know all these angles are going to be 60 degrees, correct? All these three angles are going to be 60 degrees. Now this is a square, that also you know. So what is this angle going to be? This is going to be 90 degrees. Now the next thing that you know is these sides are all equal, correct? All these sides are equal because this is a square and this is an equilateral triangle. All these sides are equal. Now if you look at this triangle, which is a triangle that we need to consider, you need to consider this triangle, correct? So when you look at this triangle, what can you see? These two sides are equal for this triangle. So what can you say with that? If these two sides are equal, then the opposite angles will also be equal. So I can say that these two angles are going to be equal, correct? Two sides are equal, the opposite angles, corresponding angles, opposite angles will also be equal. So you know what is this angle? This angle is going to be 90 plus 60, that is 150 degrees. So if you look at the triangle DEC, okay, you know this one angle is 150 degrees. So what will be the sum of the other two angles? See, if this angle is X, this is also going to be X, correct? So the sum of the other two angles will be 180 minus 150, or that is equal to 30 degrees. So sum of these two angles is 30 degrees, or I can say one angle, this is equal to 2x, correct? Sum of these two angles. So x is equal to 15 degrees. Okay, that is option A. I'll move on to the next question. Next question is there on your screen. PQRA is a rectangle and AP is equal to 22 centimeter, PQ is equal to 8 centimeter. Triangle ABC is a triangle whose vertices lie on the sides of PQRA such that BQ is equal to 2 centimeter, QC is equal to 16 centimeter. Then the length of the line joining the midpoints of the sides AB and BC is dash. Again, the most important thing to solve this question is representing it in the form of a diagram. So if you represent it correctly in the diagram, getting the answer is very easy. So if any of you get me the answer, give me the answer and then I'll go about solving the question. Okay, before we start solving this question, can some of you tell me what is the midpoint theorem? The midpoint theorem concept is very, very important when it comes to triangles. Mahata says it's 10. So can any of you tell me what does the midpoint theorem state? Okay, so as I said before solving, please tell me what is the midpoint theorem. What does it state? Because that is the concept that you are going to be using here in this question. See, if you have a triangle ABC, okay, let us assume you have a triangle ABC and D and E, let us say they are midpoints of D and E are midpoints of AB and AC, then generally this is going to be, DE is going to be parallel to BC and DE will be equal to half of BC. Okay, so this is what the midpoint theorem states. So whenever you look at a triangle and you take the midpoints of the two sides, okay, AB and AC here I have taken, this DE will be equal to half of BC. So that is what the midpoint theorem states. Okay, so you are going to use that here. Now let's just draw this whatever information that is given in the question. Let's try to represent it. So what have they said? They say that there is a rectangle, correct? PQRA. So PQRA, that's a rectangle, and they have given AP is 22 centimeters. So rectangle means this side is 22 centimeter, or I can say this is also equal to 22 centimeter, and PQ, or this side, this breadth is going to be 8 centimeters. Now what are they saying? There is a triangle ABC whose vertices lie on the sides of PQRA such that BQ is equal to 2 centimeter and QC is equal to 16 centimeter. So the triangle that you are going to draw is going to be somewhat like this, correct? B point is going to be here. Why? How do I place B is here? Because they are saying that BQ is 2 centimeter. So this is 2 centimeter and QC is 16 centimeter. So this is going to be C. So how is my triangle going to be? My triangle is going to be like that. Okay. So that's how my triangle ABC is going to lie inside this rectangle PQRA. Now what have they said? Okay, this is 2. So if this is 2, what is this length? You know, if this is 2, this is going to be 6. Now if this is 16, correct? This is 16 means what is this length going to be? See, this full length is 22 centimeters. So if this is 16, this is going to be 6 centimeters. You know, this full length is 8 centimeters. Now the question is, if you are taking the midpoints of sides AB and AC, you should know what that length is. This length is what you have to find out. Now see here, this is a rectangle. This is a rectangle here, and this is a right angled triangle. If you consider triangle ARC, correct? If you consider triangle ARC, this is a right angle triangle, and I can say AC is equal to, or this hypotenuse is equal to root of 8 squared plus 6 squared, correct? Or that is equal to root of 8 squared is 64, 36, that is root of 100, or this is equal to 10 centimeter. So I know that AC is 10 centimeter. Now you should know what is this length. Okay, let us say this is MN, whatever. Actually name is not required. So here again you use the midpoint theorem here, correct? See, you are joining the middle midpoints of these two sides. So that is going to be parallel to the third side and will be half of the third side, correct? So what is half of 10? 10 by 2, that is equal to 5 centimeters. So that's going to be the length of MN, or this line. That is option B. Yes. So I hope it's clear to all of you. Okay. See, it's a very fairly easy question. Just one basic Pythagoras theorem calculation is what you are doing. If you know this particular concept, solving it becomes very, very easy. Okay. So let's move on to the next question. Is it clear, all of you? Next question. The next question is there on your screen. So next we are moving on to circles. I think first we did a few questions on triangles, then we did some questions on quadrilateral. Now this question is on circle. So these are the main 3 figures that you need to know, as I said: triangles, quadrilaterals and circles. Again in circles, questions on tangents, then sometimes questions involving arc. All is very important. The radius of a circle is 13 centimeter and the distance of its chord xy from its center is 12 centimeter. Then the length of the chord is dash. Okay, so what is given? You have a circle here, and the radius of the circle is 13 centimeter. Okay, this is this radius, correct? This is the radius is 13 centimeter. This is 12 centimeter, and the length of the chord is dash. So again you know that the perpendicular drawn from the center of the circle to a chord will always bisect the chord, correct? So if this is 90 degrees, then what's happening? How can you find out this, right? So this is like an right angle triangle. So this length is equal to root of, let us say, okay, let us put names for 0, x, p and y. Okay. Now what is xp? xp is equal to root of 13 squared minus 12 squared, that is equal to root of 169 minus 44, correct? That is 5 centimeters, root of 25 or 5 centimeters. So if this is 5 centimeter, what is the total length of the chord? This xy is equal to 2 into 5, that is equal to 10 centimeters, correct? It will bisect the chord, means this half is equal to this half. Very, very basic question. That is option C. Okay. Now, the next question is there on your screen. Try this next question. This is on tangents. Two tangents are drawn from point P to a circle at points A and B. O is the center of the circle. Then if angle AOP is 60 degree, then angle APB is equal to dash. See again, generally now one more concept that you need to know when it comes to triangles is what is congruency and what is similarity of triangles, okay. Now see what is congruent. Congruency means two triangles are said to be congruent if any one of the following conditions is satisfied. Like let's say if 3 sides of one triangle is equal to 3 sides of the other triangle, right, then the triangles are said to be congruent. Basically the sides will be equal, okay. If you are taking 3 sides, all the 3 sides will be equal, then you say the triangle is congruent. Similarly, if any 2 sides of a triangle are equal and the angle that is contained among these 2 sides is also equal, then also the triangle is said to be congruent, right. So you have congruency rules like SSS congruency, where you take into consideration 3 sides. Similarly SAS, right, wherein you consider 2 sides and the angle that is included by the 2 sides, or ASA, that is you have 2 angles and 1 side. Now what you have to remember in congruency is that the lengths or the angles that you consider will be the same, okay. Now next, coming to similar triangles. Now what are similar triangles? See in similar triangles what you have to remember is that if you take into consideration 2 triangles, the ratio of the sides of these 2 triangles will be in a particular proportion. They might not be the same, but they are in proportion. So that's how you say whether 2 given triangles are similar or they are congruent, okay. Always keep that in mind because that comes in handy for a lot of questions, okay. That is, similar triangles are actually alike in shape only, and their the sides needn't be the same, right, for both the triangles. But when you look at congruent triangles, the sides will also be the same. So why I am discussing this to you, or why I am telling this to you, is that a similar thing that we are going to use now in this question, right. We are going to use this concept here. That's why I just said that. Now you have a circle. Now what is given? 2 tangents are drawn from a point P to a circle at points A and B. So 2 tangents are drawn means this is one tangent, okay, and this is another tangent. So I'm going to take this as A and this as B. O is the center of the circle, and if okay, O is the center means, okay, yeah, and if angle AOP, so what is given? Angle AOP means this angle is given as 60 degree. They are asking you what is angle APB, okay. Now let's look at these 2 triangles, okay. You have 2 triangles AOP and POB, correct. Now the first thing that you need to know, again a property of this tangents is very, very important here to, okay, that you should know. So if you have tangents that are drawn from one particular point, okay, one external point, here the external point here is P. So if I draw tangents from an external point to a circle, the length of all the tangents that I can draw will be the same, okay. That is, the length of tangents drawn from an external point to a circle are always equal. Or what can I say? I can say that PA is equal to PB. Basically these 2 sides are equal. That's what it means. Now next thing that you know is that, see, look at this again, when you draw a tangent, okay, to a circle, now this angle that is formed by the tangent with the center of the circle, this will always be 90 degrees. Yes, I am sure all of you know that property as well. So this angle is 90 degrees, this side is the same. Now look at this side, right, OA and OB. Again, what is OA and OB actually? Both are radius of this circle, so they are also same. So what can I say? Basically these are 2 congruent triangles, correct. See, PA is equal to PB, similarly OB is equal to OA, and this angle, both angles are 90 degrees. Now what is asked in the question? You have to find which angle? You have to find this angle, correct? So what is this angle going to be? See, angle APO, right? Now you know this triangle, so angle APO you can say this is 60, this is 90, means this is going to be 180 minus 60 plus 90, correct? Or that is equal to 30 degrees. So this is going to be 30 degrees. If this is 30 degrees, since these two triangles are congruent, this is also going to be 30 degrees. So what is this angle APB that you require? It's nothing but 30 plus 30, that is 60 degrees. So angle APB is equal to 30 plus 30, that is equal to 60 degrees. That is option, it is C, that is 60 degrees. Is it clear? Shall we move on to the next question? Next question is there on your screen. A chord of a circle is equal to its radius. The angle subtended by this chord at a point on the circumference is dash. Okay, so let's go about solving it. So what is given? There is a circle, and there is a chord which is equal to the, let us say the chord is AB, okay. The length of this chord is equal to the length of the radius of the circle. So now the question is the angle subtended by this chord at a point on the circumference. So let's take some point like that, okay. So the question is what is the angle subtended by this chord at some point, let's say it's C. Now you need to find what is this angle. Now see, first thing what is given here, this length, right? The length of the chord is equal to the radius of the circle. So what if you look at triangle OAB, what can you say about triangle OAB? See, this is radius, this is also the radius, and it is also given that this chord has a length equal to the radius. So this length is also the same. So what triangle is this? It's an equilateral triangle where all the three angles are going to be 60 degrees. So this is 60, this is 60, and this is 60. Okay. Now when you draw this figure, it's very easy to find out, okay. Now here we use the concept of arcs, okay. Now let me draw a separate figure here. See, if you have an arc, it's a circle, let this be A and B, okay. This is a theorem that you should know. It's a very, very easy theorem. I'm sure if you have studied geometry, all of you would know this, okay. So if you have an arc, let's say the arc AB, okay, the angle subtended by an arc at the center, okay, is always equal to double the angle subtended by that arc at any point on the remaining part of the circle. So if you consider arc AB, okay, if you consider the arc AB, here let the angle subtended by this arc at the center, if it is x. Now if this arc is subtending an angle anywhere else on the circumference of the circle, let's say it can subtend an angle like this, right. However it does, all these angles that this arc will subtend on the circumference of the circle will always be equal to half of the angle that it will subtend in the center. So if you know this concept, solving this question is very easy. So you can solve it in less than 2-3 seconds. Okay, so if this is 60 degree, now here what is the arc that you are going to consider? It's arc AB, correct? So this arc AB is subtending an angle of 60 degree at the center. So what will be the angle that this arc is subtending at anywhere on the circle? It's going to be 60 by 2, or that's going to be 30 degree. Okay, so the C can be here also, still it will be 30 degrees. That is option C. Okay, so using that you say it is 30. Next question. Let two chords AB and AC of the larger circle touch the smaller circle having the same center at x and y. Then xy is equal to dash. So that's the question. Okay, a lot of you are giving me the answer as option B. So let me try to represent this figure here. Okay. AB and this is C. Now what is given here? See, you have, now take this this is the center, okay. From this center, what have they said? Touch the circle having same center at x and y. So this is x and this is y. Now you have to find the length of xy. That's what is asked in the question, Ayushi. Okay. Now if you are drawing, this is the center of the circle. So if you are drawing a line from the center, from this tangent, right? This tangent is meeting this circle, small circle at x. So if I draw a line from this point to the center, this is 90 degrees. I hope you know that. Correct? Now so now look at this triangle. Consider this triangle. Take this center as O. So if this center is O, if you look at this triangle here, that is angle BOX, right? If you look at that triangle, and if I am taking the radius of the smaller circle as small r and the radius of this bigger circle as capital R, then what can I say about this length BX? I just say that BX is equal to capital R squared minus small r squared. That's using Pythagoras theorem, right? I have just written this BX is equal to, that is this length is equal to root of r squared minus r squared. Correct? So I have got this. Now next, similarly consider this triangle. If you are considering this triangle here, okay, that is if you consider triangle COY, again this is 90 degrees here. Okay, this is small r and this is capital R. You can again say YC is also equal to this. Root of r squared minus r squared will be the value of this length YC. Same concept you take here also. Okay, you take here. You consider this triangle AOY. So if you consider triangle AOY, again this is 90 degrees, you know, because this is this tangent and the center of the circle. This is small r, this is capital R. Again this AY is also equal to root of r squared minus r squared. Correct? This is also equal to AY. Same thing will be equal to AX. So what can you see here? You can actually see that AX is equal to BX is equal to AY is equal to YC. Okay. So now if you are connecting this BC here, see this BC can touch this circle, not touch this circle, that is immaterial to us right now. Okay. Now if you join the midpoint, that is if you join XY, what is XY? XY is the midpoint of AB and AC. Correct? So again, what do you know? See, you know that this is according to midpoint theorem. Now what is happening? See, you are dividing this AB and AC is divided into two equal halves, and you can say that XY will be equal to half BC. Shall I move on to the next question? That is option B. The next question is there on your screen. ABC is an isosceles triangle where AB is equal to AC, which is circumscribed about a circle. If P is a point where the circle touches the side BC, then which of the following is true? So what is given? An isosceles triangle where AB is equal to AC is circumscribed about a circle. So, okay, everybody is getting the answer as option A. Okay, so you have ABC, which is an isosceles triangle, and where AB is equal to AC. So these two sides are equal. Now P is a point where the circle touches the side BC. So this is P. Okay, now which of the following is true? So let's just take this is Q and let's just take this is R. Now again, this is one point, correct? From this point you have two tangents. This is an external point and you are drawing two tangents to this circle. So we know that from any external point, when you draw two tangents to a circle, the tangents are going to be equal, correct? Length of the tangents will be equal. So I can say BP is equal to BQ. So that is one thing I can say here. Similarly, look at this point here. What can you say? You can say CP is equal to CR. Again, from this point, see, you have two tangents, CP and CR. Similarly, take this point, AQ is equal to AR. AQ is equal to AR. This you can say. Now, what have they given? They have said that ABC is an isosceles triangle and AB is equal to AC. And so now what can you say? See, you know AQ is equal to AR. Correct? AQ is AR and you know AB is equal to BC. So what can you say? You can say that QB will be equal to RC. Correct? Or I can say all these are going to be equal. Correct? So you can say, see, since AB is equal to AC and you know that AQ is equal to AR, you can say that BQ is equal to RC. correct? So if BQ is equal to RC, then you can say BQ is equal to RC is equal to PC is equal to BP, or you can say BP is equal to PC, correct? That is option A. Yes, all of you got this correctly. See, it doesn't need so much of writing and all. Since I am explaining and some of you find it difficult, I have just elaborated it. Very easy to solve, you can get it in a second, like, okay. So I hope that's clear. We have come to an end of the questions that we have chosen for this session. So I think that's it for today's session. So all the very best with your preparation, guys, and I'll see you in the next session, and this is Gayatri signing off till then.